2, we are learning about functions. Okay, we're going to be determining whether relations are functions and also evaluating them in function notation for given values. You have technically done that type of thing before, not in the notation it's in, so that may look a little bit weird, but you will use that notation all the time. Okay, a function, it's your first vocab term. That is a relationship between input and output values. In a function, there's exactly one output for each input. Okay. Now what that means, input, those are the x values, also known as the domain values that we talked about yesterday. Output would be the range, which is the y values. So what that means is the x values cannot repeat themselves. Okay, there is one x for every y. Okay, the y values technically can repeat, but the x values may not. Okay. Now, as we're going through these, there's a couple different ways that you'll be able to check for this. The first way, what we're going to do, we're going to plot these points and we're going to use the vertical line test in order to figure this out. So if you had a visual picture of a graph, you would use the vertical line test. So let's plot all these points first. So these 5 points will go on graph A. These 5 points will go on graph B. I want you to plot them. I'm going to plot them up here, and then you need to check to make sure yours matches mine. Okay. So remember, the x value is horizontal movement from the origin. If it's positive, it's to the right. Negative to the left. Positive y is up. Negative y is down. You don't have to connect them in any way. Just make sure those are where they end up. Okay. So first one kind of looks like a squiggle shape. Other one, I'm not quite sure what shape that is. Now we're going to perform something called a vertical line test. Okay, so for those that are visual, I have my yardstick. Okay. What does a vertical line look like? Straight up and down. What's this called?
Horizontal.
Horizontal. So we're doing a vertical line test. Okay. Now with the vertical line test, you guys can use your pencil, you can use your finger, whatever. Okay. It's if you slide a vertical line from left to right, if you hit more than one part of the graph at the same time, so more than one point, it does not pass, meaning it's not a function. So if I'm sliding this across, I hit 1 point here, 1 point here, 1 point here, 1 point here, 1 point here. Did I hit 2 at the same time? No. So that would imply this is a function. It passed the test. Okay. So if you're asked, is the relation a function, you would say yes, it's a function. Okay. If it says use the vertical line test. Okay. Now the second one, does anyone see any issue?
Yes.
Where?
On the
The zero.
Okay.
Or the,
At the y-axis.
you know what
Okay. Now, if you have a grid, they're all vertical lines, so that would help. So this is just a visual aspect for those of you that may need it. So either slide your finger or your pencil across your paper. But right here, okay, that would hit those 2 points at the exact same time. So that would imply that is not a function. So this one is not a function because it would not pass the vertical line test. Now the reason for that is because the x value of 0 repeats. You guys seen the ordered pairs? There's 2 zeros in the x spot. Okay. Now we're going to discuss what that would look like in a mapping or a table. Okay. But the x value of 0 repeated, okay, which means that is not a function. Okay. It does not have one output for each input. The input of 0 has 2 outputs. That's not okay. Alright. So it's not a function if the x value repeats, or if the vertical line, any vertical line, would hit 2 points at least. Sometimes it can hit 3. Okay. Question about that? Okay. Yes, it is that simple. So that is the vertical line test. So down here, you'll see we don't have graphs. So there's different ways we can try and figure out whether each relation is a function. Okay. This is a mapping diagram. So I told you the arrows would mean something. Okay. Now you want to see if any of the domain values repeat. Now what that would look like in a mapping diagram is there's two arrows coming from the same number. Do we have that happening? Two arrows coming from the same domain value. Okay. -4 has one arrow coming from it. -2 has one arrow. +2 has one arrow. +5 has one arrow. So this one is a function. Okay. So is a function. The y values can repeat. So see how this 3 has two arrows going towards it? That's fine. Okay. But if you had two arrows coming from one number, so let's say 5 had another arrow coming from it, this would tell you there's an issue. Okay. Two arrows coming from a domain value, which would mean the x value repeats. Okay. So if these are in your homework, if you have two arrows coming from a number, so it branches out two different areas, that is not a function. Okay. This one is because every domain value had a separate y value. The y's can repeat, x's cannot. Okay. So, what do we think for D? Not a function, why?
Domain has two twos.
Okay. So you might be asked to explain. Okay, so not a function, it's all about the domain, because, okay, if you're asked to explain in your homework, I'm gonna at least write an explanation here. It doesn't say explain, but just in case it comes up. You can say it in your own words, but if you wanted to be very specific, the domain, either element or value of 2, has two outputs. Okay. Domain value of 2 has two different outputs, or two range values, something along those lines. So if you were asked to explain, I can't remember in your homework if you're asked to explain. All right, this one you can say is a function. If it says explain, you can say each domain value has its own output. Even if that output repeats itself, it doesn't matter. Okay, each domain value has its own output. This one, the domain, you can even say the domain value of 2 repeats itself. That's fine. That conveys the same message. Okay. What about E?
No.
Why?
4 repeats.
Okay, domain value of 4 would repeat. So this one is not a function. Okay. Because, so if you were to explain, again in the notes we didn't have to, but I want to give you an explanation in case, because you could abbreviate to BC. Because domain value or element, you could say has 2 outputs, or you could say repeats. Something along those lines. So be ready to explain if need be, but it can be something as simple as that every single time. Okay. If it is a function you have to explain, again, you can say every domain value has a separate output. Okay. Or the domain values do not repeat. That will convey the same message. Okay. Questions? So we're okay? All right, 5 schools are competing in the long jump portion of a track meet. The distances of the players with the best jump on each team are as follows. So we're gonna make a table. So it's been started for you. So what is the best jump for team 2?
21.5.
21.5. So go off the picture. What about 3? 20.9, 4? 19.4, and 5? 20.2. Alright. Now using that information, so we just pulled it out of the picture. So is there any questions where that information came from? Okay. Like we did yesterday, we're going to determine the domain and the range. Now, between team number and best jump, which one's domain?
Team number.
Team number. Okay. That is in charge of the situations. So the domain is going to be that roster form, so a list of numbers. Again, preferably in order. So what's the smallest number?
1.
Okay, now the team number is nice because it's just 1, 2, 3, 4, 5. Okay. But list that separately, the range, or you can write the range off to the right if you want to, depending on how small you write. Least to greatest. What would that be?
19.4.
19.4,
20.2.
20.2,
20.9. 20.6.
20.6, then 20.9, and 21.5. Again, if the book doesn't do it in order, I would prefer that you did. It's just a good practice long term, okay? Technically, it is the same thing if you don't, but try to have that practice. Okay? Now we're going to determine whether the relation is a function, and we're going to explain. What do you think?
Yeah, it is a function.
It is a function,
If
okay?
the name does not repeat.
Team number 1 didn't have 2 best jumps. They only have 1. Same thing with team number 2, team number 3, team number 4, and team number 5. So just like we explained the last one. So we would say, yes, it's a function. Okay. For the, you can be very specific, the relation is a function. Just reword the question. If you want to say, yes, it's a function, that's fine. Because what?
Each team only has one best jump. The domain does not repeat.
Okay, you can say the domain values do not repeat, okay, if you want to keep it very simply. The exact definition that you may see, okay, on different things. Each element, so if you want to write this down, just refer back to you can, of the domain. Of the domain. Has only one element of the range. Or has, I'm gonna reword that, has its own output. So the inputs should not lead to 2 outputs. It should be 1 for 1. That's called a 1-to-1 function. Okay. Now, an output can repeat because sometimes you can plug in a 2 and you can plug in a 1 to a function. They both give you the same number. That's okay. Outputs can repeat. Domain values cannot. Okay. But if it's in your own words, as long as it conveys that message to me, I'm happy. Okay. But be prepared to write it in a few different ways. Okay. Questions before we do function notation on the back? So everyone can tell what is a function, what is not a function in various methods, correct? Okay. All right. Now, equations that are functions can be written in the form called function notation. Okay. Now there's different notations for things across algebra. Okay, but function notation is a way of writing an equation so that y is substituted with, this is called f of x. Okay, so if you see it like this, f of x. Now you can have f of x, you can have g of x, you can have h of x, you can have k of x, it doesn't matter. It's a way of separating functions. Okay, so on this first one it says for f of x equals negative 2x plus 9, find each value. Now this could be the same thing as y equals negative 2x plus 9. It's the exact same thing. It's just written in a different notation. So f of x is the same thing as y. The reason that we want to apply it is you may have more than one function at a time. Okay. So you'll have it show up in your homework. Okay. So it'll make more sense the more we do this stuff. So when you have, if it says find f of 3, what do you think it wants you to do?
Insert the 3 as x.
It's telling you 3 needs to be plugged in for x. Okay? This is telling you what to input here for x. Okay? So f of 3, we've done this before. Okay? In chapter 1, I know most of you had a different teacher. But in the first module, it said evaluate for when x equals 3 and y equals 4. And you were plugging them in and simplifying down. We're technically doing the same thing. Okay? So, if you're asked f of 3, it's asking you to plug 3 into the f function, because sometimes you're going to have 3 different functions you're working with, like an f, a g, and an h. It's telling you which one to put that number in. So if it's telling you f of 3, it's telling you put 3 in where x is. So that'd be negative 2 times 3 plus 9. That's what it's telling you to do. Now you don't have to do anything on this side at all. That's just telling you what number to plug in. Okay, we simplify this down to one number, that would be the output. So order of operations, what's negative 2 times positive 3? Negative 6. And negative 6 plus 9? 3. So f of 3 is 3. Okay, now this would be the same thing if we were to make a t-chart and you have an x column and a y column. The y column would just be the f of x column. Okay, you plug in, you get an output. Okay. Now we're going to step it up a little bit. What do you think this one's asking you to do? What's this part asking you to do? Put 4 in where x is in the original function, and then it's telling you to add 3 on the end of it. Okay? So what that would look like, just since I may need more room, I'm using the same function. It would be a negative 2 times 4, because that's my x value going in, plus 9. I'm going to switch colors here. This 3 just gets tacked on the end. Okay. So you're plugging in 4 where x is, and then whatever that comes out to, you're adding 3 to it. Okay. And we just do order of operations. The more you practice this, the more it will make sense. What's negative 2 times 4? Negative 8. Okay. If adding and subtracting is left, just make sure to go left to right. What's negative 8 plus 9?
1.
1 plus 3?
4.
Okay. So the value of f of 4 plus 3 is 4. If we just did the f of 4 part, it would be 1. Okay, because we added 3 to it. Okay. So again, this tells you what number to plug into the f function. And we added 3 to the result. Okay. Now, on h, we're still using that same function, so I'll just recopy it over here since I scrolled away. You guys have it on your paper. We're still using the f function, okay, whatever letter's there. F of 5 minus f of 1. What that is asking you to do is plug 5 in for x, simplify that to one number. Plug 1 in for x separately, simplify that to one number, and subtract the results. Now you can do all of this together at one time. Kind of depends on what your brain is. Okay. The f of 5, so if I plug 5 in for x, so just this part, okay, it would be negative 2 times 5 plus 9. Just that part. Okay. Over here, separately, that would be negative 2 times 1 plus 9. So you can do them separately, you just have to remember to combine them at the end. Okay, so that's one way of doing it. I'll do it this way first, and then we'll kind of do it all together. Okay. So over here, what's negative 2 times 5? Negative 10 plus 9. Negative 1. Okay, now that's f of 5 only. Okay. Negative 2 times 1. Negative 2 plus 9. 7. So that's f of 1. Now this minus sign drops between them. What's negative 1 minus 7? So the whole answer is negative 8 for the whole expression. Now we could have done that instead of separate, and moving the sign down. You can do it all at once. Okay. So you would still split that apart. Okay. Now there's a minus sign in between here, but it applies to everything that follows. So you need to just keep moving that down, but that could confuse some of you. So depending on how your brain works, okay, still order of operations, get that all the way down to one number before the minus sign applies to it. Okay. If I had to guess, it might be easier for you guys to keep it separately, but some of your brains work a little bit differently. So if you need to do it all at once with the minus sign, be really careful. Okay. But you can do it that way. But f of 5 minus f of 1 is negative 8. questions before we do the next ones? Okay. So now I switch it to function h. So you might be given a function f, a function g, and a function h, and it might have mixed things. Use g for this one, and use h for this one, and use f for that one. So pay attention to what letters are what, because it's telling you which number to plug into which one. Okay, that's what the function notation is good for. So what's problem I telling you to do? Plug 2 in everywhere there's an x. Now there's two x's. There's one here and one here. Now, it's important on these, if you have a exponent involved, the exponent only applies to the x value. The -6 is not going to be squared with it. So be really careful when you plug these in. So I have a -6 times my x value of 2 squared. So take the time to plug these in slowly. Plus 18 times my x value of 2 plus 36. Plug that in first. Any questions on how that's plugged in? By order of operations, what do we do first? So we need 2 squared, just the 2, which is what? 4. So this is what I was talking about with the multiplying of these things. This is where the calculator would help. I still need to see the work shown, but it'll at least help prevent a lot of issues. Okay. Now we'll multiply -6 times 4 and 18 times 2. So it's -6 times 4.
-34. 37.
This?
Negative
No.
24.
28.
Negative 24.
Negative 24.
Oh,
18 times 2.
36.
36. And then 36 again. Okay. Again, add straight across. So combine the first two first. What's -24 plus 36?
Nice. So
12 plus 36?
48.
48.
I was gonna say
This is really hard.
Now, on each individual step, you need to use calculator to make sure you get the right numbers that you're combining. Because if, for instance, if we accidentally wrote 30 something here, it's going to throw this number off. So be really careful with that, okay? You can do it by hand, but if multiplication and adding and subtracting is not your strong suit, use the calculator to at least avoid those mistakes. Okay. So this is why we reviewed order of operations, so that it applies here. Now on J, again, this is similar to the third one we did with the f function. We need to plug 4 in, and we need to plug 1 in, and then we're going to subtract the results. If you want to do it all at once, feel free. If I had to guess, most are going to need to do it separately. So hopefully you're not running too big. Okay. H of 4 first. Okay. -6 times 4 squared. Make sure only the 4 is going to get squared, or anything you plug in. Plus 18 times 4 plus 36. And then h of 1 over here, same problem, just with a 1 instead.
Oh, I wrote that too bad.
Me too. It's like,
Alright. So we have the 2 halves, we will subtract the results at the end. Okay, but we need to get there first. Alright, so just make sure this minus sign drops down to the end, so we subtract the results. Okay. Now I'm kind of curious, I'm gonna give you a minute to plug in 4, get a number, plug in 1, get a number, and then subtract the results. I wanna see if we can do order operations properly. Yeah. Mm-hmm.
4 squared.
Nope.
It's just that one being 4 times 4, right?
Yes.
The other one is just a 4.
Correct.
Okay.
So you only square this 4, so that would change it to a 16, and then -6 stays in front of it. I should have probably given you guys more space on this, so I apologize for that. Raise your hand when you think you have a final answer. So the h of 4 minus h of 1.
-36.
negative 36. So if some of you are still getting there, the whole thing is negative 36. So it's this half minus this half. I will walk through this in a second. Okay, so if you're not getting to negative 36 after subtracting the two results, okay, we'll try and find the error. If you want to try K, if you get to negative 36, if you want to work ahead, you can try K. Alright. So for those of you that may not be getting it or you're stuck, okay. 4 squared is 16. Whoops. Gotta have my first
one. Oh, 4 squared. I did 4 times 2.
Negative 36?
is the total answer.
Yeah, that is.
So on this half, what is negative 6 times 16?
Negative 96.
18 times 4.
72. Yes.
Now make sure to add these from left to right. Negative 96 plus 72. Negative. Negative 24. Okay. Negative 96 plus 72.
You press the minus. You didn't press the negative. 12.
Now I'll remind you, if you're using one of these calculators, a negative is underneath the 3. It's not the same thing as a minus.
What does AMS mean?
Negative.
Okay. So negative 24, and then plus 36
See? Oh, what is it?
would be 12. Oops.
That's sad.
What? Oh. What? She got negative 96. I got negative 1.
So this whole thing comes out to 12
I got negative 1.
on this half. Okay. Now with the 1, we would get another number down here. Now 1 squared is just 1, so it's a little bit quicker. So this would be a negative 6 times 1, an 18 times 1, and a 36. So now the 1s aren't even necessary. So if technically you didn't write them at this step, then that's fine. Negative 6 plus 18 is 12, plus 36 is 48. So now what we have is a 12 minus 48, which is negative 36.
But
Yes.
isn't it squared?
What?
Okay, so if you're plugging in 1, isn't the 1 squared?
Yes, but 1 times 1 is just 1.
Oh, I did 1 times. Okay.
Did you do 1 times 2? Yeah. Be careful with that. Okay. So the h of 4 value is 12, h of 1 is 48. The difference between the two is negative 36 in that order. It is lengthy.
We did
Okay.
this last year.
You did? Function notation?
Hello.
I like to hear that. Usually that's not the answer. Okay. If it looks familiar, that's great. If not, it's okay. We'll be practicing with this for a little bit.
Like I did it, it was early in the year, so.
Yes, Jason.
Why is it that algebra is easier than pre-algebra?
Practice.
No, but like, I literally failed pre-algebra.
Yeah,
And I have a B in this class, but I literally failed
All right.
7th and 8th grade.
Let's stay focused. You guys can vent about pre-algebra later. So this one is asking you to plug 5 into the same function, but then subtract 7 on the end of it. So you can just tack a minus 7 after the plus 36 when you plug this in. So negative 6 times 5 squared plus 18 times 5 plus 36, and then tack on this minus 7, or you do it at the end, kind of like we subtracted these two at the end. I would just throw it on the end, just to make sure you don't forget. Okay. 5 squared. 25.
Yeah, she's gonna like over it.
What is negative 6 times 25?
Oh, negative 150.
Okay, so negative 6 times 25 is negative 150. 18 times 5? 90. Okay. Again, if all you have left is addition and subtraction, go from left to right. Okay. Negative 150 plus 90.
Oh.
Just these two.
200.
Mm.
Oh no, it's negative. Negative 60.
Negative 60 plus 36.
I just did plus
24. Negative 24.
Minus 7.
Negative 31.
Negative 31.
Whoa.
Each step should individually not be too bad, but this is why we have order of operations,
Yeah,
so
me
that
too.
we can plug in input values and get output values.
Wait, what are we doing before this?
Okay.
Oh, yeah. Are we gonna
So
do-
yes, use a calculator to make sure you get the right numbers, but I should still see what you're doing. Okay. Questions before the last problem, which we're doing something very similar to it, but it's a word problem, so we're going to talk more about what it means. Yes.
So like I can't do negative 150 plus 90 plus 36.7 in my calculator. I have to show all the steps.
Okay. If all you have left is addition and subtraction, so for that last one, yes, if you would like to go negative 150 plus 90 plus 36 minus 7, this calculator will do it from left to right. You will get negative 31. So yes. Okay. When you get here, then you can use the calculator to finish. Okay. But if you had to do it by hand, you should be able to. Okay. Yes, you have permission to use your calculator provided you show work. Okay, good question. All right. Mason works at the movie theater after school. The function g of x equals 9.25x represents the amount of money he makes before taxes for each hour that he works. Evaluate and interpret the function for each value. So we're going to plug these numbers in. We're going to talk about what they mean when we're done. Okay. So g of 8, what's it asking you to do? It's asking you to plug 8 in for x into the g function. Is what that means. Okay. So we're probably gonna want a calculator for this. So we have 9.25 times 8.
70.
70 what?
74.
74. Okay. Now we're gonna talk about what these mean when we're done. Okay. We're plugging 14 in for x, so it's 9.25 times 14.
129.
129.5. Everyone following? Okay. And then 27.5 times 9.25.
254.37.
Don't round it.
I rounded it down.
Don't round. What's the whole
To
thing?
7.5.
So 254.375.
Yeah.
Are we all good with the? Now this is a word problem, so they should technically have a label on them. What label would that be? It's dollars. Okay. X represents hours. Okay. So before we answer what these mean, what do you think the 925 is?
The per hour thing.
How much he makes per hour. Okay. Now, I didn't necessarily say that, but given the context of the situation. Okay. So, if I plugged in 8 and got 74, what does $74 mean?
For 8 hours, he gets.
But he worked for 8 hours. Okay. So the 8 is how many hours he worked. So he made $74. So this is the interpret for each value, if you're asked to do that. In 8 hours. Now, it did say specifically before taxes, so you really should mention that. So those of you that don't have a job yet, you could make something per hour, but they do take out federal taxes for you. It's lovely. Okay. If you get a job anywhere, aside from like babysitting, okay. If you get a paycheck, this happens. So it will say you made $74, but then it takes a percentage out. So you might only get like 60 or 50 something.
Oh.
It's lovely. Love that.
Wait, what
Okay.
is that?
It goes to federal taxes and state taxes. different things like that. Alright. Now, when your parents do taxes in April, they get some of that back later. Okay, so if you ever hear them talking about doing taxes, they get some of that back. Okay. Question?
So for B, would it just be like he made $129.05 in 14 hours? Okay.
So the next one, this is saying you worked for 14 hours. So he made $129.50. So since money can be 2 decimal places, you would need to tack on the 0. Okay. In 14 hours before taxes. Okay. Now, can we technically round money to 3 decimal places? No. Okay. So if hourly, let's say you did work 27.5 hours, okay, that will be rounded up a penny because that is a 5 and it's 5 or higher, so that would be a 0.38. Okay. So generally employers will round up if it's an extra decimal place. Okay. You never know, some may round down. So he made $254.38. In 27.5 hours before taxes. So, is everyone clear with function notation? It's telling you what number to plug into which function. That's all it's telling you to do, because you might have 3 different functions. You might have an A function, a B function, a C function, and it might be C of 4 minus B of 2. And you'll use 2 different functions. Okay. Questions on determining whether something is a function or using function notation?